Every single website you've ever visited started with a question sent to one of just 13 answers hidden at the center of the internet. When you type a domain, your computer doesn't understand words, it understands numbers. So it asks a giant phone book called DNS to convert the name into an IP address. This translation happens billions of times every single day, silently in milliseconds. But that phone book has a top, a starting point, and if that top ever went dark, finding anything online would collapse. At the very top of the DNS system sit the root servers. They don't know every website. Instead, they point you toward who does, like a librarian directing you to the right shelf. Every domain on the planet, from .com to .org, ultimately traces back to this single layer. Here's the shocking part. This entire top layer is run by just 13 root server identities, labeled A through M. 13 letters, quietly deciding whether the internet can find anything at all. And here's the strange part. The entire root is served by systems labeled with just 13 letters, A through M. Back in the early internet, a single DNS response had to fit inside one small network packet of 512 bytes. Only 13 server addresses could squeeze into that space without breaking the message. So the number 13 wasn't chosen for luck. It was a hard limit of the plumbing itself. And here's the wildest part coming up. You don't actually need these 13 very often, and that's exactly what protects them. Those 13 names are not 13 machines. Through a trick called Anycast, each identity is copied into hundreds of physical servers scattered worldwide, all sharing one address. In total, well over 1,000 real machines answer as those 13. Anycast works like magic. When you send a request to root server F, the network automatically routes you to the nearest copy, maybe one across town instead of across the ocean. If one location goes dark, your request instantly reroutes to another, and you never notice. You'd think all this happens constantly. Actually, the root servers are almost never bothered, and that's the secret to their survival. In 2002, and again in 2007, massive coordinated attacks slammed the root servers, trying to flood them offline. Several were knocked down. But because the load was spread across so many copies, the internet as a whole barely flinched, and ordinary users saw almost nothing. So the next time a page loads in a blink, remember, it began with a silent question, answered at the quiet root of everything. To prove the root data hasn't been tampered with, the system is protected by cryptographic keys. Changing the master key requires a real-world ceremony held in guarded facilities, where trusted people from around the globe physically appear. It's part cybersecurity, part sacred ritual. And the keys to that lock aren't held by one person. The wildest part is coming because there's an actual ceremony. Around 14 people from different countries hold pieces of trust for the root key system. No single person can act alone. Control is deliberately split so that no one government or company can quietly seize the internet's foundation. And there's a ceremony you've never heard of, held in a locked room with physical keys to protect all of this. The 13 root identities are run by 12 independent organizations, universities, agencies, and nonprofits. There is no single boss, no master switch, and no company that can turn the whole thing off. This scattered ownership is a feature, not an accident. But could someone just knock these servers out? People have tried, with brute force at massive scale. That file is the root zone, the master list telling the world where every top-level domain lives. It's tiny, but if it were corrupted or maliciously altered, lookups everywhere could point to the wrong place. That's why it's signed, versioned, and watched constantly. That resilience isn't luck. It's the whole point of spreading 13 names across 1,000 hidden machines. This system is called DNSSEC. It lets your computer verify that an answer really came from the true root and wasn't swapped by an attacker along the way. Without it, someone could redirect you to a fake bank site, and you'd never know the difference. So the busiest system on Earth is actually one it's designed to bother as rarely as possible. These root instances now sit in over 100 countries, tucked inside data centers on every continent, including Antarctica. Spreading them this widely means an attack in one region can't starve the rest of the planet of answers. Every video you stream, every message you send, silently leans on these 13 addresses to know where to go. On a normal day, the root system fields tens of billions of queries, and during attacks that can spike far higher. Yet response times for most users stay in the milliseconds because the load is shared across all those hidden copies. And every time a page loads instantly, this entire invisible machine just did its job, silently. 13 names, 12 operators, thousands of machines, and one signed file. That's the fragile-looking backbone holding up everything you do online. It survives not because it's unbreakable, but because it's spread everywhere, verified constantly, and owned by no one. 13 addresses, quietly keeping the whole web alive, built so no one can ever pull the plug.